let's talk about one of the distributed system properties called consistency. When we say consistency, we are talking about data consistency. We know that in a distributed system, we'll have many nodes and those nodes could be distributed across the world as well. When we say data consistency, we refer to accuracy and reliability of the data across all those nodes. Okay, that is what consistency means. So if all the nodes have most up-to-date data, then we would say that the system is in a consistent state. But if some of the nodes have up-to-date information and some of the nodes have stale information, then we will say that the system is in an inconsistent state. Let's understand this in detail with an example. Let's imagine that we have a database with 2 replicas. So basically we have 3 copies of the same database. Now, if you write something to this copy, then we want that change to be propagated to these 2 copies as well at the same time. Otherwise, this database will have most up-to-date information, but these 2 copies will not have that information. So the database will be in a consistent state. If you're reading from this database, you'll see the latest information. If you're reading from these other 2 copies, then you'll not see the latest information. This might be a problem as well, right? So when a database is in consistent state, the data that we have written to this copy is propagated to these 2 copies as well. So that is when the database is in a consistent state. Okay. So we have many levels of consistency which define how this consistency is achieved. So I'm not going to talk about all of the consistency levels, but we have 2 most common consistency levels and they represent 2 extremes. On one side, we have something called strong consistency, and on the other side, we have something called eventual consistency. Let's first start with strong consistency. So strong consistency means when you write something to one of the copies of the database, the write operation will not complete until the data change is propagated to the other 2 copies. Okay, so that is what strong consistency means. Strong consistency is useful in a scenarios like, bank transaction. When you are doing a bank transaction in one of the copies, you want that transaction to be reflected in other copies immediately. Otherwise, it might lead to some issues. For example, if you are making a money transfer using an app which is connected to this copy, and at the same time, if another, let's say, for example, subscription service that you have is trying to collect the subscription payment from this database, if you don't have consistent view of the data between these 2 database copies, then it might lead to issues. For example, the subscription payment might go through even if you don't have enough money in your database because you already transferred all the money from your account to some other account in this database, right? So when we follow strong consistency, these kind of issues can be avoided, and strong consistency is one of the suitable consistency level for this kind of banking transaction. But the downside of this strong consistency is that it is going to be slow, right? So these database copies might be distributed across the world and there could be many such copies as well. So when your change is written to this copy and you wait for that copy to be replicated across all these other copies before you confirm to your client saying that this write operation has completed successfully, which is in this case money transfer, right? So that is going to take a while. So that is the downside. So latency is the downside, but accuracy and reliability is the upside. So with strong consistency, latency is the problem. But the advantage is accuracy and reliability. Now, the other extreme is called eventual consistency. In eventual consistency, what will happen is when you write something to one of the copy, for example, we write to this copy, there is no guarantee that the data will be propagated to other 2 copies, in this case, immediately. But the guarantee is that it will be propagated at some point in future. There is no guarantee that when it will be propagated. If there are no updates to these databases, then eventually at some point in time, all 3 databases will reach a consistent state. But there is no guarantee in terms of times. So in eventual consistency, when you make an update to this database, and if you read the same data from this database, then you might see a stale copy of the data. You might not see up-to-date copy of the data. And in some applications, this is acceptable. For example, when you are actually posting something in Facebook, for example, if you're posting a picture in Facebook, then not all of your friends will be able to see that immediately. It will take some time. It will take some time for the data to be synchronized across all the Facebook databases. And once it reaches the database which is closer to you, then you'll be able to see the change, right? Eventual consistency is still useful for these kind of applications. Okay, so that is what eventual consistency is. So the advantage of eventual consistency is that this is going to be fast. Okay, so we are going to have fast writes because we are just going to write to one of the copies and we are not going to wait for that to propagate to other copies. But the disadvantage is the data will be inaccurate. Okay, so the data will be inaccurate. So that is the drawback of eventual consistency. So like I said, there are many different consistency levels between strong and eventual consistencies. We are not going to go through them in detail in this video, as the focus is just to understand what consistency means. I hope this is useful. Thank you.